a wonderful concept called architecture. Before getting to actual topic, we know the basics. What exactly means the architecture? What mean the server? What mean the client? All those things you need to understand. The first architecture is nothing but is a systematic arrangement of hardware and software application components. Okay. So, software applications. What are those? Those are servers, or I could say services. Simple server. So, what are services? When you say, usually we call it a background process. Technically, we call them background process. Everything in the world, whatever you release in the market to deploy on a particular operating system and platform, that application should some background process in order to run that application. Say every application which is released in the market to run that application which process, that itself we call them services. Collection. Build a single software or single application, then we call it as node. Now, a collection of nodes are called collection of nodes are part of architecture. I could say. Not easy, I could say architecture. Now let's look at here. When you architecture, what kind of type of architecture right now in the market? How the architecture evolution happen, and what many types of architecture we have? The current trend. We are going to learn now. The value called referred as service is ordered as background process of any application. And what it does, that act what exactly it does? It does or user sends the request. It means it responds the request. It responds to user request. When you say user, we refer here client. Usually refer here client. Technically, it's not the person say, it is client. So what is client? This client we usually call them is another machine, and we send the request. Client is a machine through you can send request to server machine. Both are only, but one machine, if you would like to train some request, you need to fetch the data from particular application, or you want to fetch some data from the database. So if you are trying to use it, that is called client machine, and you send the request which respond and give back to your response. I mean, which give back your output or response. That machine itself we call them server. So beginning any application which are I could say 1960 to 70 time, and that time you were using IMS. I hope you guys are remembered. There was a first concept called MIS. Later we have the first software was entered in the market is called IMS. So this IMS is nothing but is a kind of a software which can be a computer rather than storing information to the file-based system in the type and documentation and all. Usually we used to keep all the information about the business in the computer software. And the software which was installed in the computer, it was dedicated to that system, that software only. So then it was called it as completely one-tier architecture. One-tier architecture. What is the meaning of one-tier architecture? So application software as script application get installed and used system is called one terabyte. So the use in a one single system is called, I say, you say instead of use, I could say access. System called one terabyte. But when perfect concepts were used like database, the database concepts were into the file-based system, then DBMS system, RDBMS system around 1960-70 time. On that time, when the database softwares are introduced in the market, at the same time, a lot of other software applications also introduced in the market. So they wonderful innovative concepts. Those are called two-tier architecture. Two-tier architecture. Think of this two-tier architecture. Similar way, you have to install software. Access by keyboard system. You would install software one place, but you can access the same software to many different clients. Between two-tier architecture, one-tier architecture. So n number of clients. Through that you can request and you can get from the server. It's called texture. The best example we talk about package database or SQL developer server, reporting solutions, let's say reporting tool, like any other ERP software, or I could say business zero applications, or two-tier architecture. You could add server by setting one single machine. It could be a computer, desktop computer, and it could be one more computer, and it could be one more computer. There is no limit. You could access the same information, whatever you want to fetch from the particular information about the customer or particular product, particular database, or particular orders and sales. In case you would like to do that, you want to access information from the database. What do you do? You install the software into this machine, and the software you could say client software. By installing software, you could example SQL Plus. SQL Plus. For example, SQL has something called SQL client. Tools also entered in the market, that is called tools. Through this software, you would access databases. Similar with business objects. Suppose you take example here, business object. A BO software in client BO client software. IPGUI, X. Like this software you are accessing your server software. This was the concept introduced in 1960s itself. But with this two there were some limitations. With this limitation, there are lots of drawbacks are also rediscovered, and this also helps on degrading the performance of retrieving data from database. What are the two-tier architecture? The first thing is, in order to access the server, you should install minimum client software. Obviously, minimum client software, you cannot get access to the server. So when you client software install means every machine should have this software, otherwise you cannot access. Similarly, you should purchase software, client licenses also. You purchase licenses of clients. Now it consumes resource, machines. You have a lot of PCs, consumes network. Many you have in order to access means the server will be located on one place and a client will be located in something. So you access data from this database. It will be taking a lot of time to make connectivity from one system to another system. So that is one drawback. So the biggest drawback of this two-tier architecture is there is no queue mechanism. There is queue mechanism. What meaning of it? Suppose example the PC1 sender request he wants to fetch the data about the customer, and the second PC also is, for example, at 9 a.m. the first PC person to send a request, and the second person going to send a request. I mean 9:30. Person also sends a request like 10 o'clock. He wants to fetch the data about order and sales. However, if even though the 10 o'clock the person which is firing a query which takes very less time, even though it's very critical for your business, you want to get as less possible compared to these two people, but this query not run unless these two query requests are completed or satisfied. So that means no queue mechanism. So all the three things will be run on the flash directly on the server. At a time the request will go. So one a lot of burden, everything, all these three requests will automatically get. So these 9 of these keep on running. It may be taking around 1 hour, 2 hours. In 9:30 class also it's taking 1 hour. 10 o'clock people have started running the query. What will happen? It won't, this start query, these three automatically run on the same machine. So it not go for one by one, and all the queries will become at a time to the server. This is okay when you say one query, two query, third query. But just in that, suppose you have thousands of machines, PC2, PC3, PC4, PC5. Like this, all the 5 users are send a request at a time in a single minute gap, or I can say single second gap. All the 5 requests will be fall under the data server automatically. Since 5 is like the thousands of requests are coming and falling onto the server side, since there is no mechanism, there could be chances of the server software get crashed. Server system may get crashed because there is no queue mechanism. Obviously, there is a huge burden to maintain this request. Due to that, it will be get crashed. So this situation, there are many scenarios, many companies work for for losses and big risks because of this and load. And there is no mechanism for load balancing at the server side. This kind of two-tier architecture, there's many people are vendors and have come up with a wonderful new concept that is called three-tier architecture. Three architecture. These all problems. Now going for here. So now, these system machines across the world, you have a lot of PCs, a lot of users are there, and many people want to access the data, what is happening in their business, and they are generating the reports and accessing through PCs, desktops, and tablets and mobile phones and everywhere. All over you have millions of the customers are there. Everybody wants to see what is happening into their business. They want to see their transactions, their account transactions, their customer details, order details. Everybody keep on sending the other requests. All these requests will be first managed by this particular component is called application server. So there is one more component introduced between server and client, application server. So this web application server, this is called web application server. So that is usually stands for, we call them WAS. what exactly does, it completely manages all the requests. It's a management tool which will have handle all the requests. So I can say this is called request management tool, which all the requests from client. Now server capacity, and it can service, it can serve a response of user request at a time. But still, if you know maintain this, queue proper methodologies, like going for queue is a first come first service. In order to maintain this first come first service, it will come up with a wonderful concept called is a 3-tier architecture. So you have the server, web application server, and the client. So what is here is through web application server, there is one more advantage here is install any client software. You could access server directly through via web application server. So you could go access through via application server. Here, when you send a request, there is no need of installing the client server. Simply you open the browser and you can access your server software. So that is a major advantage. It means it's avoiding your client software installation, of systems. Whenever you install or upgraded, you have to keep on installing and updating each and every piece. That request not right now there, because you can access through browser. Since your browser update will be happen automatically through this browser, you could access all the servers. Mentioned stuff it became all the requests has to go only web application. Some flexibility here. You can access server machine, not web. You could also access directly through client. It's nothing but use this 3-tier architecture also flexible for to interact with the server and client machine. So whenever you go server and client software architecture, it is now 2-tier plus 3-tier architecture. So these are major advantages when compared to 2-tier architecture is 3-tier architecture. Now let's look at what is HANA architecture. Something different completely. So let's look at. Now let's understand the HANA architecture looks like. This one focus here, since is HANA is a database. Let's understand you have server is nothing but is a database server, and also you have client machines. You would like to access the HANA through client machine, and you need to install client software. That client software we call them here HANA. Studio. The database server. HANA application, and this database server is a database, and this HANA database obviously contains n number of servers. Just now I told you this is a server machine, but server is but it contains n number of servers. I told you database is application. Since the application, obviously it would be having some background process. Database, since it is a database application, then it definitely some background process in order to run this database. So that process we also call server service. Usually you can as a service. Now what are services are available in our SAP HANA databases? There are only services. The first one is index server or service, whatever you prefer. Then it is called name server. Next one called preprocessor are also called service. The next is called analytics. Then it's called server. Then it's called common server. Plenty of services. Now, what are these services and what are the roles when you make your HANA database? You would access all your database just simply installing the HANA client software in a particular machine through Studio. You could access your HANA database server. But now, in order to access this database server, that backend you have plenty of services. How these services working together and how exactly helping users to retrieve them from the HANA database. That we are going to learn now. Server is the core component, is a major component which actually manages entire HANA database. Manages entire database operation. Like creation, deletion, updates, alter, all activities related to database, loading, extraction, confirmation, all those things will be completely managed by index server. So this service very, very important. This index server, it is the one major component of your HANA database. Without this, HANA database will not be get up. It is the major one. Without this, you cannot run or you cannot start up your HANA database. See, one of the important thing about here is, I told you today that is HANA server deployment can be done in a single system or distributed environment. When you say single system, when you think, but we already discussed to have one single HANA database instance, then there should be 100% index server. So it means environment. But I told you, in single database instance is nothing but you would be having single motherboard as a hardware point of view, motherboard and CPU, and it will be having a number of CPU. So there is no for that. But in case to maintain more than one single motherboard and you want to go for distributed environment, so what would happen here? So that time this you will be going to use board. In that situation of services should be installed in this one. There is option for you to install all these other services: name server, statistic server, DB server, daemon server, processor. But it is necessary you install index server. It means based on the looking at the index server, we will come to know whether it is a distributed environment or single environment. It is a single system or standard environment. So standard nothing but the single system application, server kind of architecture, but still I can say it is single deployment. When you have more than one index server, you easily guess that, you can easily say that it is a complete distributed environment. So index server plays a vital role when you talk about distributed environment. Next service is called, and this vital role especially in the distributed environment. Why so? Especially plays a vital role distributed environment. Why? Because it maintains services, each and every machine, all details about what are the servers are running and what are the machines are they running, what are their port number, what are their instance number, what are the IP numbers, each and everything maintained. All your landscape details will be maintained by name server. So what meaning of instance? To deploy any HANA database. Say example, you install single system HANA database and you want to install one more database. So what can, even you want to consider all these database servers should be considered as one single system. In that situation, what happens that time that we call them, instead of database server, this is a database server, you usually say it is the first instance, it is the second instance. So instance will be giving a number called 00, it will start with something called 001, like this, go for up to 65. So you can install a number of instances of databases. So that will start something 00. So when you install index server here, the first is installed, given a number here 00, then you give a 01. This is an instance. So whenever the 00, that index one name, the port number will be suffixed with the 0. Similarly, second database install also going to suffix with 01. So the index server, we have a number called port number. That port number like this. Port number kind of syntax, a systematic number. This is like this. 3XX1. This is the port. Here the XS will be replaced. The XS will be replaced by your instance number. So what would happen, since you have index server 1 and index server 2, in order to identify how many instances are there, or what are their instance number, those things of information will be managed by name server. But port number, each and every index server will have some identical unique number. The unique number itself we call them a port number. So name server will give the particular unique number to for each and every index server. Let's look at how the index server port number will look like right now. Number will be like 30015. Second server port number will become 30115. So now this will become like this. So based on this number, based on this port number, name server will identify that whether these index servers are up or running, and what are the system name, what are their IP address, what are their host number, and what are their index server port number. This will be managed by name server. Now let me understand what I mean by IP address, port number. What is the main difference? That will be giving a number. Given a number to identify uniquely on the network system, to identify uniquely on. Similar way, this is a giver to location to identify which gets installed. This gets installed. Like say you have a environment like this, you have a development, quality, production. So in that situation, the development database and quality database, production database, all these three systems are on the same network. But how do you need to differentiate whether you are connecting to development database or quality database or production database? In order to differentiate, you will be using this number called the concept called port number. You will be using HANA Studio only, same client software, but you need to access different servers. You would like to access the development server, access the QA server, action server. So in order to access through client software using a single client machine, but you would access to a different that can be possible with the concept port number. So that same port number is given in the HANA database for services called index server. So through index server port number, you could come to know whether connecting to development environment or quality environment or production environment. And you also have, I said, development be having the single instance server or single index server, or you can have more than one index server. So this in development also you can have more than one port number, because each will be having increment with a 002, 001, 02, like that. Information about into landscape and all index server information will be in the name server. Then the next preprocessor. The preprocessor server completely mirrors unstructured data. I told you HANA database is popular for structured data, especially, but at the same time, it is also handles entire all unstructured data also. So structured will be completely managed by this processor service. It is a all text analysis. Suppose you think called long text, which is called, it will maintain the all long text will be split by the tokens, and it will maintain all those information with the maintained by, handled by, or controlled by this service called preprocessor server. The next one is called statistics server. A simple server, simply information what is happening in your environment, just like it maintains the information about all other services. All other services are there. What are their performance? What are their consumption? What is the status? What is the position? Whether startup, whether it is running, or whether broken, or whether failed, or whether they are having a lot of load or not. All those information will be managed by statistics server. It maintains information about all other services. At the also information about data, base, tables, views, objects, procedures, everything. Would say simple database, objects, say artifacts. Okay, so it contains all the information. How much time it is taking to create a table? How much time taken to load the data into the table? How much time it is taking for retrieving the data from the table? How much load is on there while retrieving the data from the table on the particular services? All those information will be managed by this statistics server. It is completely give the performance information about entire all other services. At the same time, all transaction, operation, whatever you are done on the doing on the database. That is the uses of statistics server. The DP, nothing but the data provision tool, so which helps to manage completely all your SLT operations. SLT, continuous system landscape transformation, that will learn in the next section. Maintains completely data provision. So it's nothing but yesterday we learned, day before yesterday we learned some kind of wonderful concept called ETL, extraction, transformation, loading. That in order to do those kind of activities, we have some tool called SLT. That tool information, all activities, whatever you are performing on our database, all provisioning. Extra transformation loading concept we also referred as provisioning, data provisioning. The provision activities, everything will be managed by completely DP server. The next is daemon server. What is daemon server? Daemon core server, I could say it is a mother server, or I could say instead of one, I would use the word it is a kickoff server. So to start up all other services, this will start and it will kick off all other services. So kickoff server or start server, which or make it up other services. Whenever database get up, the first thing is the daemon server monitors that whether index server gets up running or services servers or name server is started keep on running. All other services whether running or not, everything will be managed by daemon server. So it is kind of a group, or it can be kind of a batch file which helps you to kick off other services. So this of all the services will be installed, deployed by automatically when you deploy HANA database. So this HANA database can be deployed any platform, especially only I could say SUSE Linux. U2 could be installed in any other operating system. Unfortunately, they are limited. This HANA database can be installed only Linux. SUSE Linux. So our application can be deployed only HANA SUSE operating system. On this Linux operating system, when you install a database application, HANA database, automatically these all 6 servers will be get install. Other than 6 services, you would be getting a lot of other services. It's all depend upon the application, the license which you are purchasing. Suppose you are purchasing select HANA server with only the server, then you will be getting this RAL. Suppose you deploy this HANA database server based on the BW powered by HANA. Suppose the BW also will be get installed, then some more extra services also you would be able to see in the HANA system. So at this point, these are the default server get installed, and these are the major role what they play when you talk about HANA database. These are major services, main services which play a vital role when you are running the HANA database. This architecture, now can I create a 2-tier architecture or 3-tier architecture? That we will go and discuss tomorrow, because writing this time is running over. So tomorrow I would like to cover some other concept which is extended to the same concept. Whatever I covered, we need to learn something new concept that is called special concept, and it is also called applications that we learn tomorrow. So tomorrow we whether can I call as an architecture, 2-tier architecture or 3-tier architecture. Then we can. There are some leftover. What do you mean by what options are available in this one? And exactly this engineering is helping you while accessing the HANA database through HANA client or HANA Studio. So that we will discuss tomorrow. If you have any doubts, please let me know. So I will try to answer within a couple of minutes. Then we can wrap it up. We can continue tomorrow.